Hello world, Joshua here. I have spent the last kind of year or so doing some tool development for Jubilee, and I wanted to share that with you today. So we'll go through kind of what's here on the table, and I'll walk you through why I'm really excited about them. Okay, so let's start off with the tool in the center. Okay, so this is the Syringe Extruder, and the idea is I want to give Jubilee the ability to extrude pastes. And so the idea here is I take a 10cc syringe, I load it with a paste of my choice, be it peanut butter or solder paste, and then I simply install it into the extruder. And so there's a tab on the top that I want to catch, and then there's a tab at the bottom that I want to catch. And so that should go in like so, that should go in like so, and it fits in quite well. Once I'm here, I can add rubber bands here for support, in case I'm worried about this popping out. And then we're pretty much ready to actually extrude with it. In software, this shows up like a extruder, where you simply define your steps per millimeter, and then your extrusion diameter is driven by the Lurlock style tip that you want to stick on the end of this. And that's variable. You can decide whatever you want based on the kind of your syringe diameter of choice. So that's that. I must say overall, this took a few revisions to get this working really nicely, but I must say like it's really, really smooth. It feels really good in your hands when you're actually loading and unloading syringes. It just overall has a really great tactile feel to it. So I'm really happy with how this came out. And then like all the other tools in Jubilee's library of tools, it has the classic tool ball pattern, and then these like O-rings here to kind of retain the tool and keep it from popping off of its parking post when you're not using it. So that's kind of it on the Syringe Extruder. That's been out for quite some time at this point, but I wanted to kind of showcase some of the things I was really excited about with it. Okay, so let's move on to our next tool. Okay, so up next is the camera tool. I'm really happy with how this came out. So the idea here is that I want to give Jubilee the ability to inspect objects on the bed, be they kind of layers of your printed part, or maybe circuit boards that I want to apply components to at a later step. But inspection is one of those parts of those processes. So what's going on here is I've built this around a Raspberry Pi HQ image sensor breakout, combined with an ArduCam breakout. So the result is that on the other end of this tether, this ArduCam interface gives me a USB interface to this camera, which is really convenient if you're doing any sort of image processing. This is a really nice way to hook it up to your computer. Okay, so the idea behind this tool was to give people a lot of flexibility. I don't really know what people are going to be taking pictures of, so I want to give you lots of options. And to do that, what I did is so the nice thing about the Raspberry Pi HQ sensor breakout is that it takes C and CS mount lenses, so I can pop this lens out and put in a variety of other kinds of lenses in here, no problem. The other thing too is something that's really important about taking pictures of tiny things is illuminating your subject. And so I've seen people do this on all sorts of different ways. Normally though, the kind of classic way to do this is to put this like ring PCB of LEDs, and I wanted to give people a little bit more flexibility, so I found something a little bit different. This is actually side illuminated LED strip. It's actually cob LED strip, so it's coming off of this reel over here, and the idea is I'm not necessarily sure what the diameter of your lens is going to be, so I want to give you an option that's very flexible to be able to accommodate a variety of diameters. So that's the idea here. This stuff is super bright. And it's side illuminated, so it's going to shine down on the subject when you wrap it around this printed part. So overall, I wasn't sure what people are going to be taking pictures of, so I wanted to make sure that you have the flexibility of being able to swap the lens and the illumination feature in and out, so you could essentially get yourself more flexibility. A couple of things I'm really happy with. Overall, this came together really cleanly. It's tight. This shroud actually is hiding the O-rings, which are used as the retention feature to be able to park the tool in when you're not using it. And overall, I'm really happy with how clean that ended up coming out. It's all tucked in and hiding inside of there. So that's the camera tool. Okay, last but certainly not least is the CNC Touch Probe. Okay, so the idea here is I want to be able to pick up this tool and inspect objects that are on the bed. And so that might be features of the bed directly. Maybe I want to use this as a Z probe to kind of probe for the limit of my bed, or maybe I want to inspect objects that are actually installed in the bed. Maybe I want to scan the top surface of a 3D print to figure out exactly where I left off, or maybe I want to measure the dimensions of something that I loaded into the machine. So that's kind of the idea here. First off, just a couple things right off the bat. It's really, really tiny, and I like that. Just to give you a sense of scale, here is the Syringe Extruder by comparison, just to see how small it is, which I really like. It's one of those things where I feel like it should be no larger than it needs to be. Okay, so I guess a couple other things that I wanted to bring up is the compactness partly comes from how I did the parking post embedding of the O-rings. Just as a quick reminder, the way Jubilee picks up and drops off tools when it's not using it is it actually mounts them into these parking pins when they're not being used. So this model is parametric, it's sized according to this tool, and the idea here is that the carriage just drives up to the parking post and plugs it in. And when it's ready to go, it just pulls it out and we're ready to use it. So this ended up being a really nice clean interface. Something I should mention here is that internally inside of this model are O-rings, and they are acting as a retention feature. So the machine's going to vibrate. That's not anything we can really prevent. And what you really want is you want to make sure that your tools don't fall off when you're not using them. And so that's what these O-rings do as a consequence. But it still ends up being a nice clean fit. So that's kind of the second thing I wanted to highlight. Okay, so how this actually works, it's actually, it should be very familiar to you if you've seen the construction of touch probes before, or if you're kind of honing in on the way Jubilee does its kinematic coupling based tool locking and unlocking. So I'm going to pop this open so you can see what's going on in the inside. Okay, so no surprises. Inside is a kinematic coupling. The way this shows up in software is a limit switch. I'm going to take these wires off for a minute, and I'm going to try to zoom in and see if you can see a better view of what's going on. Ah, yes, much better. Okay, so the way this works is there are two pins here, and this is where our signal is going to come out from. And then we have a kinematic coupling that is actually attached, where the upper half is actually attached to this Z probe tip. So what's going to happen here is that I'm going to physically take my ruby tip and bump it up against things in the real world, and that's going to upset this coupling, and it's going to kick this coupling off of the 6 points. So what that does here is these balls and pins are actually all electrically connected together. They're joined in series, and the wires are exposed, or the two ends of that circuit are exposed here. And so all it takes is kind of a micron level movement to pop this off, and you're able to upset that complete circuit, and that can register as a limit detected in software. So I'm going to kind of be way more generous here. The coupling's never going to move this much in real life. But what's nice about this sort of construction is that it's sensitive in all three directions, X, Y, and Z. And I really like that. At the end of the day, I made a little circuit board to make the kind of interface a little bit easier to assemble, but you don't have to. This you could easily do with wires. It would be a little bit more cumbersome, but it's doable. So that's the idea here. And then finally, of course, there is a spring for retention feature so that we always know that when we're not probing anything, we're still making that electrical connection. So that's kind of it as far as the construction goes. But I just wanted to give you a sense of how this all works on the inside. So there should be no surprises. Okay, that kind of wraps things up for the end of the year. Like all the other tools and the rest of Jubilee, all three of these tools are documented. They have a bill of materials, they have step-by-step instructions, and a list of printed parts. So if you're curious, I'd say go over to the wiki page on the tools list and you'll find everything you need to actually build one of these. Feel free to use them as you like, be it a reference, be it a direct copy, or be it improvements. I'd love to see what you build. Okay, that's about it for documentation. I also want to give a special thank you to the Hacker Initiative Foundation, which gave me a lot of support this year in being able to actually do further development on these tools. If you're interested in taking your open source work and sharing it with other people, I would definitely look them up to see how they can help you reach out to a larger community of people and continue development on your own work. So that's about it for now. and we'll catch up next year where I have some more exciting things that I want to share, but they still need some extra work. So we're not quite there yet. But in the meantime, enjoy and happy hacking.